Okay, welcome to the Year 13 mock solutions. So I'm going to start with question number 1. Part A. So we're given a model, A equals 105 minus 12e 0.08t. Part A asks to state the surface model area of the pond covered by the weed at the start. So if we're at the start of the investigation, we've got t equals 0. So A equals 105 minus 12 e 0.08 times 0. This will be 105 minus 12 times 1, because this is going to be e to the power of 0, and e to the power of 0 is 1. So we get 93, and don't forget to include the unit, which is meters squared. Part B says find the time taken in days to one decimal place for the surface area of the pond covered by the weeds to fall to 40 meters squared. So we substitute 40 as our area into the formula, and then we have to solve. So to solve an equation with an exponential in, you firstly have to rearrange to make the exponential the subject before we try and cancel it. So we rearrange, I'll put the 12e to the 0.08t where it's positive on the other side. I'll subtract 40 from both sides, and I'll divide by 12. Only then can you try and cancel the e. And to cancel an e to the power of, we use the inverse, which is natural logarithm. So I take natural logarithm of both sides. Because natural logarithm is the inverse of exponential, that will cancel. 0.08t equals log 65 over 12. So t equals log 65 over 12 divided by 0.08, which gives us an answer which rounds to 21.1 days. Right, so the question tells us t is measured in days, and it asks us to get it to one decimal place, so it's 28.1 days. Part C then asks us to predict the surface area of the pond covered by the weed 30 days after the fish are introduced. Explain why you should not use the model. On these questions, it's always going to be the same. They'll give you a numerical value, and we need to investigate what happens with that value. So when t equals 30, let's place that into our formula and see what I get. And hopefully, we're going to get an idea of what to do from there. So this tells us that A is minus 27.3. That's the first mark. So we've got the area is minus 27.3. We can't have a negative area. We can't have a negative area. That doesn't make any sense, does it? So you can't use the model. Right? Obviously, something's gone wrong with the model. When we get to 30 days, it's predicting a negative area. So that's an invalid model. So we need the A equals minus 27.3 and then a conclusion about not being able to use the area because of the negative model. Okay, question 2. Let's have a look at this then. So question 2 is, again, going to use logs. It says, given that, and I'll write that down, given that 2 log 3 minus x minus log 21 minus 2x equals 0, show, and it's x squared minus 4x minus 12 equals 0. So anytime we wish to solve or cancel the logs, so we need to cancel the logs, we need to start off by making it into a single log term. Just like with the exponential, you cannot cancel logarithms until you have it as a single term. So I firstly use the rule that allows me to put the 2 into the power at the front, and then I've got subtraction, so I can combine them into a single logarithm, 3 minus x squared all over 21 minus 2x, and that's all inside that logarithm together. Right, single logarithm equals 0. When you've got that a single logarithm on one side, no number in front, we can cancel it by putting it to the power, both sides to the power of the base. So in this case, it doesn't say what the base is, right? But hopefully we know that if the log doesn't have a base, it's base 10. Even if you didn't know that, because we've got 0 on the other side, it's not going to matter. So when we've got putting both sides to the power of 10, that will cancel this log here. So we'll end up with 3 minus x squared over 21 minus 2x equals 10 to the power of 0. Now 10 to the power of 0 is 1. So from there, we have equal to 1. Now, even if you didn't know it was 10 and you used some different base because you were confused, you would still get 1 there, right? So you could still get to the right answer. So now from that point, we need to simplify this equation and get it to be a quadratic. So we've got a fraction, so let's remove the fraction by multiplying both sides by 21 minus 2x. 21 minus 2x times 1 is just 21 minus 2x. Then I'm going to expand this bracket and move everything over to that side, and hopefully we get what the question is asking. Let's just double check that. Yep, x squared minus 4x minus 12 equals 0. Then part B. Part B, I write down the roots. So the roots, obviously the solution. So hopefully you can see I can factorize it like this, x equals 6 or x equals minus 2. Then it says state which of these two roots is not a solution to the original equation. So you've got to remember with logs that you can't have a negative log. Can't have log of a negative. So let's check each of these solutions in the original equation. 2 log 3 minus, and now I'm going to substitute in, so this is when x equals 6, I'm going to substitute in 6. 3 minus 6 minus log 21 minus 2 times 6 equals 0. That would give you 2 lots of log minus 3 minus log 9 equals 0. Well, that one's all right, but this, you can't have that. Log minus 3 doesn't exist. So therefore, right, x equals 6 is not a solution. Right? On the other hand, if you want to check x is minus 2, when we put minus 2 in, it would be 2 log 3 minus minus 2 minus log 21 minus 2 times minus 2 will give you 2 log 5 minus log 25 equals 0. And you can see both of my log terms have positives on the inside, so it's x equals minus 2 is a solution. So anytime you're solving an equation with logs, you've got to substitute the values back in to check that you've not created a situation where you've got a negative inside the log leading to a math error. Okay, question 3. So question 3 is a classic binomial expansion one. Let's have a look. So we want to find the first 4 terms in ascending powers of x of the binomial expansion square root 1 plus 4x. Okay, so the first thing we need to do with square root 1 plus 4x is we need to put it in a form that will allow us to use the binomial expansion. And that is with the power of a half rather than the square root. We then are using the formula for binomial, right? 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 x cubed all over 3 factorial, etc. We only need the first 4 terms, so they'll be there. Now that's in the formula book, so you need to consult the formula book and hopefully you can find it there. Now, what are the values we're substituting in? Well, n is equal to 1/2, that's the power. And instead of x, we're going to substitute 4x. Right, because this is the binomial expansion formula is for 1 plus x to the power of n. But we've not got 1 plus x, we've got 1 plus 4x. So let's pop all that in. 1 plus a half times 4x plus a half, half minus 1 over 2 factorial x squared, etc. And if you put all that in correctly, you should come out with 1 plus 2x minus 2x squared plus 4x cubed. That's 4 marks for part A. Part B asks us to explain why x equals 25 over 4 should not be used. Okay, so anytime they're asking you about the binomial expansion, you've got to understand that there's a limit on when we're allowed to substitute values in. So for the original binomial up here, is when the modulus of x is less than 1. Now, in our case, we've not got just x. We replaced our x with 4x. So the validity of this is only when the modulus of 4x is less than 1. We can divide both sides by 4, so we need the modulus of x is less than a quarter. So let's have a look at 25 over 4. Well, we can say that 25 over 4, the modulus of it is bigger than a quarter, right? Therefore, our expansion is not valid for x equals 25 over 4. Okay, so you got to check the validity and show that you can't substitute that in because 25 over 4, the modulus of it is bigger than a quarter. Part C, another classic part of these binomial questions, then asks us to explain how you could use x equals 100 to find an approximation to root 26. There is no need to carry out a calculation. Right, what have we actually got from above? We've got that 1 plus 4x is equal to approximately, right, it's not an actual equal, it's an approximately equals to 1 plus 2x minus 2x squared plus 4x cubed. So it's telling me we need to use x equals 100th. So if we put x equals 100th in, that would approximately equal to whatever 1 plus 2 times 100 minus 2 times 100 squared plus 4 times 1 over 100 cubed. Now what have we actually got here? So on this side, you could put this into a calculator, right? But it's 1 plus 4 over 100, which is equal to the square root of 104 over 100, which is equal to square root the top and the bottom, so whatever square root of 104 is, over 10. But actually, this is equal to root 4 times root 26 over 10, and this is 2 root 26 over 10. So what we've got, so we can then cancel that as well, root 26 over 5. Now you could have just used your calculator, right, at that point and come straight out with root 26 over 5. That would be fine. So if I was to substitute x equals 100 into this expression like I've done here, right, this bit, what we're saying is that that is approximately equal to root 26 over 5. Not root 26 is approximately equal to root 26 over 5. So what do I need to do? Well, I would substitute, because it's asking me to explain, it doesn't want me to do it. So step 1, this is my answer. Substitute x equals 100 into the binomial expansion. And that would give me an estimate for root 26 over 5. So step 2, if that's root 26 over 5, and I want to know what root 26 is, I would multiply my answer by 5. Like that. Okay, and that's question 3.